So I'm dimensioning some cold rolled steel, and normally I can't get any kind of surface finish on it, but the truth is I've never tried pushing it this hard before. If you take light cuts, it's terrible. So what I did was I am taking fairly heavy cuts, 100 thousandths depth of cut, and also the feed rate is up at 7 thousandths a revolution, and then you get a pretty decent surface finish out of it. It's very frustrating because I've never been able to do it otherwise, but so I'm trying to take this last bite at 101 thousandths to take everything I need at one time, because otherwise I'm gonna have to take light passes and then the finish will go to hell. So also my RPM, 680 RPM. If I did it slower, also I wasn't breaking chips, which is why I started speeding things up. But the surface finish is pretty fantastic, especially for cold rolled and hot rolled steel. This is cold rolled, I think. All right, so if I did this right, this will be on dimension and a really nice surface finish. And oh, look at that, 2/10 over. That'll work. Ooh, actually 7/10 under. That'll still work. This is the shaft that the bending arm rotates around. So we needed 1.5 inches, and it's 1.4992. So it's about a thousandth. So that should be good. So we got to bore out the inside here. By the way, here's the chips it was making. Some unbroken, some broken, but nice, beautiful blue. All right, just drilling to 3/4 inch depth. We're actually going to go just shy of that. We're going to bore the final size out. So next up, before I bore this out to final dimension, I thought what I'd do was something that Tom doesn't have on his drawing, which I don't think will hurt anything, but it'll make it easier when I flip this over to drill the holes and find the center, which is to drill a rough hole. There is always a risk when you're drilling a hole like this, though, that the drill bit will wander, but I don't think it's too precise. The holes on the other side are just for the cap, the retaining cap, and that floats on the outside of the bending arm, so I don't think that's going to be a problem. And if I take this slow, I think I should be able to get a decent hole. We'll just try it and find out. Oh, you saw that wobble? I saw that wobble. Never mind. I'm going to try a stubbier drill bit. Nope. I think what I need is a center drill, something a lot more rigid than this, and then do this guy. All right, so no wobbling there. That might give me a better chance. Guess initially we'll hunker up on this screw machine drill bit. Oh yeah, that's a lot better. Now that we got it started, go to a longer drill bit. Okay, that should work. So now we're just going to bore out the inside. Okay, so that's a dead-on fit right now. So we need to take off just like a few tenths, which means sandpaper. Okay, so a little bit of sanding. That's the kind of fit I want. Oh, that depth is perfect. Look at that. That sits perfectly flush. That's exactly what I wanted. Piston fit. So we're going to call that good. This cold rolled steel though, or hot rolled steel, yikes, is it a horrible finish in there. Probably because I wasn't taking big bites. Yeah, anyways. Looks like I got the drill bit length nearly perfect. This is actually 50 thousandths long, so I still need to face this guy off to final length. That was pretty high speed parting. That was 440 RPM with this Kennametal tool. It works really well. These are quite expensive, but I think worth it. As a parting tool, it's pretty amazing. It does a much better job than the inexpensive Chinese knockoff ones, and the inserts are far superior as well. Well, today, this is my go-to calipers. I've been using these since Shars sent them to me like 3 or 4 years ago, and they're my daily calipers. And interesting, I use the thumb wheel a lot to position this, and the only thing that holds the thumb wheel on is a plastic piece that has 2 pins, 2 little plastic pins, and a it threads into one little plastic post, which broke off apparently, or came unglued. I can't really tell, but that's an unfortunate design choice on their part, my guess. I'm going to see if I can glue these back together and continue using them because I like them. But something to note, I told you I'd give you feedback as more came in, and more has just come in. So I faced off the other side, and I used a center drill to get the angle right. I have a 60-degree angle center finding thing for my just a rod that I ground to center 60 degrees, and I use it for finding centers of parts when it's not critical, and this is definitely not critical. So we're going to do that, and we're going to drill and tap the 3 holes in the bottom. This is the method I use when I'm only looking for a few thousandths accuracy on center finding, and since I put the bevel on here that matches this, which is incidentally a piece of tool steel, I drop this down, and then I go back and forth and see what the distance is on either side, find its halfway point, both X and Y, lift it up, re-put it in, and do that over and over. And I find that I get within a couple thousandths. So I'm going with that method because these are just bolt holes to mount the 3/4 20 screws that will hold the plate on the bottom. And so they're going to have a lot more latitude than just 1 or 2 thousandths. This isn't super precision work. I have compared this method to the Blake style, and it compares favorably. That's how I verified that it's a couple thousandths. The next step is to drill these 1/2-inch deep holes, tap for 1/4 20. It's on a 1-inch diameter bolt circle, so I'm just going to use the bolt circle feature of my mill to do this, to make this hole, and should be just fine. And he set the depth at 1/2 inch, but you could actually go deeper and not run into this inner bore, which is interesting. I guess if you want to make it for different length thread screws, if you have very limited selection, you don't have to cut them off and clean up the ends of the screws, you could go a little bit deeper and not run into the bore on the other side, but I'm going to follow Tom's recommendations. And we're done. So tapping blind holes, power tapping blind holes is risky. I was using the DRO on my quill. I left a couple tenths extra depth so that I wouldn't bottom out. The first hole was really close to hitting it or hit it. I was better on the second ones. All right, so here's the finished part, and it's done. This hole was not spec'd by Tom at all. I put it in on my own. It just seemed like it would make it more convenient for me to align this, so I used it. And Another thing to note, the next part is the plate that goes over this. The bending arm rotates around this piece, and so the plate holds it and prevents the bending arm from falling off the bottom. So that's the next piece to make. And the last part will be the bending arm bracket because it's the most complicated. Now, to get a better idea of what's going on, this part here gets welded right there on the side, on the top and on the bottom. And this will challenge my welding skills because there is a moderate amount of rotating force on this because the arm is mounted low on this. So it is going to try and put some rotating force to make this try and fall off of here, which is going to make my weld more important. The top part needs to be flush. So I'm going to run a weld bead down the center there. Then I'm going to have to re-mill this flat over here. It should be challenging. Hopefully my welding skills are up to it. I'm not sure they are. I'm a mediocre welder at best. Tom has also started as a welder, I think, so he's more or less an expert welder. But the fit's great. Well, I made the last piece off camera, and it might have been interesting to show. I wasn't shooting it when I was doing it, but this is some hardened shaft steel. And it was interesting to work with because it was about Rockwell 25 on the outside, and the inside somewhat softer around Rockwell C 8 to 10. But it cut really nicely and left a great finish. This piece goes underneath this piece, and then the part that I still have to make slides over this. Now I cheated a little bit. This is the part I just made, which just leaves me with this piece and the bronze bushing. But rather than buy a big chunk of bronze to make this 1.5 clearance 1.75, even if you buy the hollow bronze, you'd be spending some big bucks. And at McMaster Car, they had these bronze bushings, the exact right size, already done for me. This one's heavy duty, and this one's regular duty, bearing sleeves. So I thought I'd give them a try and see how they work instead of making my own. Because, like I said, these were like $5 a piece, and the bearing bronze just for 6-inch section would be about $100, and that's on eBay.